Polynomials.com.
Next is the relationship between the coefficients and zeros of a polynomial. Relationship between the zeros and coefficients of a polynomial. See, what is the standard form or general form of a second degree polynomial? Do you remember the general form or standard form? Ax square plus bx plus c, where a, b and z are real numbers. This is the standard form of a second degree polynomial. Since this is a second degree polynomial, it will have two zeros. A second degree polynomial means with degree 2 will have two different or distinct zeros, and sum of the zeros of this polynomial will be equal to sum of the zeros will be equal to minus b by a. Minus b by a. B is the coefficient of x and a is the coefficient of x square. Then sum of the zeros will be minus b by a. If the two zeros we are assuming to be alpha and beta, if alpha and beta are the two zeros of the polynomial, if alpha and beta are the two zeros of the polynomial, then alpha plus beta will be equal to minus b by a. Then alpha plus beta means sum of the zeros alpha plus beta is equal to minus b by a, and product of the zeros, product of the zeros will be equal to c by a. C is the constant term and a is the coefficient of x square. C is the constant term and a is the coefficient of x square. That is alpha into beta, product of the zeros alpha into beta will be minus alpha into beta will be equal to c by a. Alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. In words we can write this as sum of the zeros, that is sum of the zeros is equal to minus coefficient of x, coefficient of x divided by a, coefficient of the term x square, coefficient of x square, and product of the zeros, product of the zeros is equal to c by a, means constant term, divided by a, coefficient of x square, coefficient of x square. Now ax square plus bx square plus c is the standard form or general form of a second degree term, second degree polynomial, and ax cube plus bx square plus cx plus d is the standard form or general form of a cubic polynomial or a third degree polynomial. Ax cube plus bx square plus cx plus d is the standard form or general form of a cubic polynomial. Then sum of the zeros alpha plus beta plus gamma. If since this is a third degree polynomial, there will be three zeros. If alpha, beta and gamma are the three zeros, are the three zeros of the cubic polynomial, then sum of the zeros, then sum of the zeros alpha plus beta plus gamma is equal to minus b by a, and the zeros taken twice at a time and the product, that means alpha beta plus beta gamma plus alpha gamma, which is equal to c by a, and product of the zeros and product of the zeros alpha into beta into gamma, alpha into beta into gamma will be equal to minus d by a. These are the relationship between the zeros and coefficients of a polynomial. See, for a second degree polynomial, sum of the zeros alpha plus beta will be equal to minus b by a, and the product of the zeros is equal to z by a, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. And for a cubic polynomial, that means a polynomial with a degree 3, sum of the zeros alpha plus beta plus gamma is equal to minus b by a, and zeros taken twice at a time and sum alpha beta plus beta gamma plus alpha gamma is equal to z by a, and the product of the zeros alpha into beta into gamma is equal to minus d by a. It is minus d by a, product of the zeros. These are the relationship between zeros and coefficients, and we have to check the relationship among these zeros with the coefficients. We have to check by doing problems. We can check this on later. Okay.